Welcome to Math with Mrs. Bibb. A student reached out and asked me, pardon me, I want to turn on that light, asked me about domain and range. And so I wanted to do this video to help with domain and range. As I look at, I see a mistake I made. It says find the domain and range of each function. And this is not a function. I'm not going to find the domain and range of that. Why is number 5, let me move that up to where you can see it. Why is number 5 not a function? This line, x equals 3, is not a function because it fails the vertical line test. So this one's not a function. I'm not finding the domain and range. Okay, now let's look at the other ones. Look at number 1. The domain and range of a relation or a set of ordered pairs is found by naming the x-coordinates for domain and the y-coordinates for range. Well, let me find these ordered pairs. This is -1, 1. This one here is 0, -2. This ordered pair here is 2, 3. So my domain is the set, and that's what these braces are for, the set of x-coordinates. My x-coordinates are -1, 0, and 2. Really, they should be in numerical order, but it's okay if you don't put them in numerical order. The range are my set of y-coordinates. So my y-coordinates are -2, 1, and 3. Now, the video that I provided shows you graphs of functions that look like this. Let me show you one. Okay. So there's my x and y plane, my coordinate plane. And you actually have like starting points and stopping points. So make sure to watch that video that I provided in Google Classroom in the assignment for graphs that actually stop. But I want you to notice this is ongoing, this is ongoing, and this is ongoing. So there's 2 ways to name the domain and range for continuous functions. This continues, actually this continues forever. Okay, let's talk about domain and range. The domain of just a graph in particular is how far left or right the graph goes. So for this graph, how far to the left is this graph going? Hopefully you can recognize it's going forever. How far to the right is this graph going? This graph is going forever to the right. So my domain is either the set of all real numbers, or you will find that we're going to express it in interval notation, which you do not have to do that right now. The set of all real numbers in interval notation is from -infinity to +infinity, because on a number line, because that's all the coordinate plane is a horizontal number line and a vertical number line. On a number line, -infinity is all the way to the left, +infinity is all the way to the right. So how far to the left is this graph going? It's going forever to the left. It's going forever to the right. So either one of these is acceptable for the domain and range of a line with positive slope, or domain for positive slope. Let's look at range. Range is how far up or down the graph goes. So when I look at this graph, and again, remember, this is just a number line. This is -infinity, going forever down. Going forever up, this is +infinity. How far down is this graph going? How far down would I have a y value that I could name as a coordinate on this graph? Well, it's going to go forever down as well. So my range is all real numbers. I'm sorry, I crammed all that together. Or I can also say it as negative infinity, because it goes from negative infinity to positive infinity. These are always in numerical order from smallest to largest. Now let's look at this one, the domain. How far left and how far right is this graph going? Hopefully you see it's going forever to the left. That arrow tells me it's going forever to the left. It's going forever to the right. So you can say the domain is all real numbers, or you may say from negative infinity to positive infinity. This is called interval notation. Either of these answers is acceptable. Now students are quick to just go ahead and slap all real numbers here, but let's talk about this. The range is how far up or down the graph goes. Well, is that graph going forever down towards negative infinity? No, it's not approaching. It's only going to the left, and it's only going to the right, but it's not even going, oh, I put negative infinity to positive infinity. It's not even going up. It's just a horizontal line. Well, let's think about this for a second. This ordered pair is 0, 2. What's that ordered pair? Negative 1, 2. What's this ordered pair? Negative 5, 2. What's this ordered pair? 6, 2. Do you notice a pattern? Every single y coordinate on this graph is going to be 2. So the range is just 2. Okay, let's move on to the next one, and that'll be all for today. For this one, does it change when your graph has positive slope or negative slope? Domain is how far left or right. How far towards the left is this graph going? It's going to rise to the left, up and to the left forever. So this graph is going forever towards negative infinity. And how far down to the right, down and to the right is this graph going? It's going forever. So my domain is either all real numbers or from negative infinity to positive infinity. And I'm perfectly okay with you using this answer here. And then my final one, my range. Remember I said a second ago, this line is going up and to the left forever. So that means it's going towards positive infinity since it's going up forever. And I also said it's going down and to the right forever, which that down indicates negative infinity. So my range here is also all real numbers or negative infinity to positive infinity. And remember, either one of those is acceptable. It's perfectly fine with me if you just use all real numbers. And again, we're not naming the domain and range of this because it is not a function, because my instructions say find the domain and range of each function. Okay, I hope that helps, and I hope you have a wonderful day. Thank you.